All right, section 3.8, that's what I'm calling it, is radical equations. And we're going to take a look at this section at some more stuff with radicals, in particular how to solve when radicals are involved. So we're going to start with something real basic. And the whole idea, when we keep working through these, they'll become more and more complex, is to isolate the radical and then square, or cube, or power 4, whatever we need to, okay? Isolate the radical and then get rid of it. So our first couple of problems, it's already going to have it isolated. We don't have to do that part of it. So if you take a look at number 1, the square root of w is already isolated, right? It's by itself on one side. So in order to undo a square root, we would square. All right, squares and square roots are inverse operations. So the square of the square root of w would be w, and then the square of 6 would be 36. Okay, so every problem we work is going to eventually look something like that, where I've got a square root by itself, numbers or variables on the other side, and we have to square. Number 2, again, isolated variable already. I'm going to square. But when I square the left-hand side, what will I still have remaining? I'll have a y minus 6. I'll have all of what's underneath the square root still there. And what is 5 squared? 25. So what would we still need to do? Add 6. You got it. So what would y equal? 31. Okay, everybody good so far? Nice. Okay, number 3 and number 4 do not have the square root isolated. So if I need the square root to be isolated, that means all of this stays put. But what happens to the 2? It's got to be subtracted, right? It needs to be moved. So I'm going to start by moving the 2. So the square root of w plus 11, and it'd equal 1. And now the problem looks just like number 2. What will I do? Square both sides. So that gives me w plus 11 on the left. What will I have on the right? 1. 1 squared, so nice. It's just 1. And then my last step would be subtract 11. I don't know why I wrote 10. Probably because I'm ready for the answer. Subtract 11. And my answer would be negative 10. Right? Okay. How about number 4? I would subtract the 3 over. And I have the square root of x minus 9. What's 1 minus 3? Negative 2. And I'd like for you to pause right there. At this point, if you're pausing right here, hopefully you'll recognize, and if not right now, you will later, that there's no solution to this problem. So now that I've said that, any idea why that would be true? Why would there be no solution to this problem? How's it different than the problem before? It's not because there's a negative underneath the radical. It's a good guess. There's a negative on the other side. Yeah. When we take square roots, we always get positive values. What's the square root of 25? Well, it's 5. Right? The only time we get pluses or minuses are when we don't start with the square root, but we put it onto the problem and we have to add the plus or the minus, you know what I'm talking about? But square roots values are always the positive value. So I can't get a negative 2 here. Now let's just suppose for a moment that you didn't notice that and you kept going. So let's continue on and I'll show you what would happen if you continued going, okay? So let's go ahead and square both sides as though we were going to try and solve this. We weren't recognizing. I'd have x minus 9 equal 4, right? Add my 9, and x is 13. Now, let's actually check to see if the solution works. So, I have 3 plus the square root of 13 minus 9. What is square root of 13 minus, or what is 13 minus 9? 4. What's the square root of 4? 2. And 3 plus 2 is 5. And 5 does not equal 1. Right? It doesn't work. So somewhere along the way, if you're being careful to sort of check your solutions, we will be forced in a moment to check our solutions. But if you check this solution that you thought you arrived at, it won't work. It just won't work. So there is no solution to this problem. Yeah, that's what I would recommend. So if I were doing the problem, I would have stopped right here if I noticed it, and hopefully I would have, and hopefully you will too. So all you had to really write down and do would have been that part, and you could have said no solution here. Okay? So please be mindful as you're working through these problems, because if you recognize there's no solution, you have less work to do, right? You do. You definitely do. All right, let's take a look at number 5. On number 5, what would we do first? Move the 2. We're going to add 2 to the other side. And now that we're aware that there could be a problem when we do that, it'd be a good idea to check and make sure, am I going to have a solution when I see it at this point? Yes, it's equal to a positive number. So what would my next step be? Squaring, right? So what is the left-hand side squared? 9. And what am I going to have on the right-hand side? 3v plus 18. What would I do next? Subtract my 18. So that's negative 9. And then divide by 3. What v value do I get? Negative 3. Now, I'm not going to check every problem with you, although you certainly can check it on your own. But let's check this one just so you can see they really do work when they're supposed to work. The last one I showed you wasn't supposed to work and it didn't. So let's just check to make sure it really does in fact work. So v is supposed to be negative 3. So I'm supposed to get 1 when I do this. So I have the square root of 3 times negative 3 plus 18 and then minus 2. I always have to go back to the original equation when I'm putting things into check. So what is 3 times negative 3? Negative 9 plus 18 would be positive 9, right? Negative 9 plus 18 is positive 9. What's the square root of 9? 3. And 3 minus 2 is 1. So this is my sort of check step. Either you check mentally or check physically. We're going to be required to check here in a minute, and I'll show you why. But it works, right? It does, because the square root was set equal to a positive number, not a negative. How is 6 different? There's 2 radicals. You know what, though? It doesn't really matter. Because when I solve it with 1 radical, what do? I square both sides. So what happens when I square both sides here? Yeah, all the radicals go away. So I have 5v plus 7 equals 2v plus 13. Really not different. Maybe it looked different to begin with, but it really wasn't. So what would I do next? Combine like terms, subtract a 2v, sure. So I have 3v plus 7 equals 13. Then what? Subtract my 7. It's a 7. So 3v equals 6, divide by 3. V is 2. Okay, the next two problems are actually different, right? Looking at number 7, oh my goodness, there's a typo on it for sure. That should say x underneath there, so it should say 5x minus 6. Don't mix up your letters, that would be weird. So aside from my typo, what about this is different than the previous problems? Besides the fact that I screwed up my variables. There are 2 variables. Yeah, well, there were 2 variables over here on the last one. Yeah, we actually have a variable that it equals instead of a constant. So at the point where the variable is isolated, it's equal to a variable, right? All the other ones, once I got to the isolated variable part, it was equal to a number, right? And I could look at it and say, oh, look, the number's positive, I'm going to get a solution, or, oh, look, the number's negative, there's no solution. But here, because it's equal to a variable, I don't know what that variable is. That's kind of the point I'm supposed to be trying to find. And if that variable is negative, it's not going to work. And if the variable is positive, it will. So when we're working with problems that have a variable like this that it's equal to, when we get to the end, we got to check the solutions we have. Sometimes they'll both work, or 3 of them will work, or 2 of them will work, or 1 of them will work. Sometimes nothing works at the end. We just won't know until we get to the end and check them. So let's take a look. The radical is isolated. So the process works the same way. That is to say, I'm going to square both sides. On the left, I get x squared. What do I get on the right? 5x minus 6. And at this point, I have a quadratic equation, right? Yeah. So quadratic equations, I have to get everything on the same side and 0 on the other side if I want to try and factor it. And if we can factor, that's usually the fastest way to do the problem. So we kind of like to try and factor before we try anything else. So if I move the 5x and the negative 6 to the other side, I'll have x squared minus 5x and plus 6. Does that factor? Yeah, it does. What does it factor into? Okay, is everybody okay at this point? So the fact that it factored into 2 pieces means I'm going to have 2 potentially correct solutions. What would I do next? Yep, I need to set each part equal to 0. What will the first x equal? 2. And what will the second x equal? 3. There's a couple of things you could do. On this particular one, the original equation already had the radical isolated. So the reality is I really need to only check that on the left-hand side, when I plug it in, I get a positive number. And x equal 2, x equal 3 are both positive numbers. However, sometimes it doesn't actually start like this, right? It might have some pieces moved around and whatever. So if you wanted to, or if the problem necessitated that you had to, you could check the solution completely. So let's just check the solution completely just so we can see what it would look like in general. In general, I need to check each number into the actual equation I was started with. So here's my 2. And then I have the square root of 5 times 2 minus 6. So what is 5 times 2? 10 minus 6 is 4. The square root of 4 is 2, and it works. How about 3? Well, I have the square root of 5 times 3 minus 6. What's 5 times 3? 15, and 15 minus 6? 9. What's the square root of 9? 3. Again, it works. So both of these solutions actually work. X is 2, X is 3, and we're done. They both check out. What are you doing? You didn't say anything. I heard your voice. All right, cool. Let's try another one like that, okay? So this problem looks a little different. How does it look different than the last one? It has two u's in it. Okay, the last one had two x's in it once I fixed it. What else? What's that? There's a negative underneath the radical. Okay, we've had some negatives underneath radicals. All right, you got it, Karen. On the left-hand side, we've got the radical isolated, yeah? I mean, that part's done. But the part where it's equal to now is not just equal to a single value. It's equal to a variable component and a constant component, right? The last one was just equal to x, a variable. So the process works the same way. We're going to square. But what I want you to notice is that when you square the left-hand side, you actually have to distribute it out, right? Please don't go telling me that's u squared minus 1 squared. It absolutely is not. It is u minus 1 times u minus 1. Now the right-hand side, of course, the square root of the square gives you just the negative 14 plus 6u. But on the left, what do we get? U squared. What else? Minus u, and plus 1. It's distribution, right? We're distributing the u through, we're distributing the negative 1 through. Okay, negative 14 plus 6u. Okay, so I have u squared minus 2u plus 1. Now what? Combine like terms. So right now, the u squared is on the left, and it's positive, so I kind of want to move everything to the left. You know, everything moving over that way. So I can add my 14, which adds to the 1, and I can subtract my 6u, which subtracts from the 2u. Negative 2u. So what do I have? U squared, then what? Minus 8u and plus 15. Again, there's no guarantee that it's going to factor, but if it does, that's the easiest way to continue through the problem. So we'd like to try. Does this one factor? It does. Into what? Minus 5 and minus 3, yeah. Okay, everybody good? Okay, what's next? Yep, set each one equal to 0. So I have u minus 5 equal to 0, u minus 3 equal to 0. What values do I get for u? 5 and 3. Did I skip problem 8? That's the one I wanted it to be. Okay, never mind. We'll finish this one, but then I guess the slide didn't make it in. I'll write it out in a second. Okay, so we need to check it, right? We need to check it back in the original equation to see if it works. It's like looking at my paper. Where did number 8 go? We'll get there. All right, so if we check the number, what did I have first? 5. So I have 5 minus 1. And we want to know if that equals the square root of negative 14 plus 6 times 5. So on the left-hand side, 5 minus 1 would be 4, so that's good. On the right-hand side, I have negative 14 plus 30. What does that give me? 16. And what is the square root of 16? 4, so this one works, right? And then I have 3. So I have 3 minus 1. And we have the square root of negative 14 plus 6 times 3. So, wow, that wasn't supposed to be there. 3 minus 1 is 2. 6 times 3 is 18. So what's the square root of 14 plus 18? Yep, square root of 4, which is 2. That one checks out. So on this one, both of these solutions for, was it u? Yeah, u equal 5 and 3 also work. Obviously, I'm trying to get to a point where I can show you one that doesn't work. So you ready to show you that one? The one that I skipped. Okay, let me put it here. Number 8, the one that I skipped. This is a terrible background. So at least make it not so scary. Okay. Let's see. Let's do this one. That's the one I wanted. All right, we're going to square both sides just like we had done before. What's the square root of w plus 6 squared? W plus 6. And then on the right-hand side, I have w squared. So far, so good? Okay, great. I need to move it all onto the same side. Do you want to move it to the right or to the left? To the right? It'll keep the w squared positive. So I will minus my w and subtract my 6. So I have 0 equals w squared minus w minus 6. And we will attempt to factor. It works. How does this factor? Minus 3 and plus 2. All right. So I said each part equal to 0, right? So what does w equal? 3 and negative 2. Okay, so those are two potential values for w, and we need to check them. So I have the square root of 3 plus 6 equals 3. So what is 3 plus 6? 9, so the square root of 9, and what's the square root of 9? 3, so this one works. And now I have the second check is for negative 2. Negative 2 plus 6. What is negative 2 plus 6? 4. And what is the square root of 4? 2. And what happened? These are not equal, right? So what that means is that w equals negative 2 is not really a solution. It's called an extraneous solution. It simply means it's a solution that comes about from the algebra that you're working with, but it doesn't work in the context of the original problem you were given. So the only solution for this is actually w equals 3. Okay, I skipped problems 10, 11, 12, and 13. We will finish those next time. They won't take us very long, but they'll take us longer than the 2 minutes we have. So I'm going to go ahead and give you the homework for this section. That way you have it if you would like to start working on it, because otherwise you're going to have 2 sections for sure over the weekend, because the next section that we do won't take me very long for it to be done in class, okay?